You've made models of them, you've made jokes about them, you've made up songs and poems and art about them. It's time to meet the mole. Okay, so the mole is not the cute little furry creature here with the large front appendages and the well-adapted digging tools and very, very diminutive little eyes because they live underground. The mole is actually the SI unit for amount of a substance. So you are familiar with SI units for length, for mass, for luminosity, the candela. But the mole is the SI unit for the amount of a substance. And 1 mole of anything is the amount of substance that contains the same number of pieces as 12 grams of carbon-12. That gets into the mass definition, which we're going to do in a little bit. But the one that you should start off worrying about is that a mole of stuff is 6.022 times 10 to the 23rd pieces of that stuff. That's known as Avogadro's number. What's the green stuff you put on tacos? Guacamole. You know, it's made of mashed up Avogadros. One of my favorites. Nobody came up with anything like it. So that's a mole of stuff. You can think about this just like thinking about a dozen donuts. If I tell you to go get a dozen donuts, how many donuts are you getting? 12. A mole is just like a dozen. It's a way of describing the number of pieces of something. It doesn't matter what we're counting. This is like you can have a dozen of anything. You can have a dozen tea kettles. You can have a dozen mice. You can have a dozen darts. You can have a dozen pieces of paper. Same thing applies for moles. If it seems over the top, you got to drive that point home. It's the number of things. Avogadro's number is how many are in a mole. And this is what we just said. This is just the number of pieces in a mole of anything. Is Avogadro's number. Now, Avogadro, Emilio, he's got like 6 names because he was minor nobility. Avogadro didn't actually come up with the number, oddly enough. He came up with the idea that there would be such a number. And so, hence, when they figured out the number, it was named for him. So it's 6.022 times 10 to the 23rd particles, pieces, items, things, donuts, chipmunks, dirty socks, M&Ms, Reese's peanut butter cups, whatever. 6.022 times 10 to the 23rd. Why is this useful? Oh, you're going to see. Well, it's useful because we can go out from the number of pieces to what their mass is. And because chemical reactions happen between one molecule and another molecule, or one atom and another atom, we have to nail down this kind of math to do any kind of work with chemical reactions. Molar mass, the mass of 1 mole of a pure substance. And basically it is the atomic mass expressed in grams. So the atomic mass of carbon is 12.011 AMUs. The molar mass of carbon is 12.011 grams. I forgot to record that. 1 mole of iron equals 6.022 times 10 to the 23rd atoms of iron, and it also equals 55.85 grams of iron. Okay, anytime you have 1 mole of something, its mass is the atomic mass in grams. The only difference between atomic mass and molar mass. So, pick your favorite element, Michaela. Magnesium. We love magnesium. Magnesium has an atomic mass of 24.31 AMUs. It has a molar mass of 24.31 grams per mole. It's the only difference between the two is the units. So on a test, if I ask you, the molar mass is given in what units, you're going to say grams or grams per mole. If I ask you for the atomic mass, what units do we measure atomic mass in? atomic mass units. I know, that one's so creative, isn't it? You will have a brief little tutorial video, little 9-minute, 10-minute video tonight on using these facts to do basic intro conversions, and then we will practice them together all day tomorrow. So you'll have, like I said, 10-minute video, some practice problems, and then tomorrow we will work together on getting good at that. So that's it.